You are one of the most outspoken voices pushing for these images from NASA. They're convinced it's just a comet. Are you convinced?
Thanks for having me, Natasha. Well, the verdict should not be decided by administrators at NASA. It should be decided by the data. And in fact, the best image that they offered at the press conference indicated that there is fuzz elongated. There is some glow in front of the object in the direction of motion, not in the direction of the sun, as we might expect from evaporation of pockets of ice as a result of illumination by sunlight, or the push of the gas that comes out of those pockets of ice opposite to the direction of the sun. Instead, we see it perpendicular to the direction of the sun, in the direction of motion. And the question is whether this is a beam of light or a beam of particles that are used to clear out any micrometeorites that might be impacting the object as it moves forward. So to me, it raises more questions than it answers. And then
Right now, social feeds are screaming about a potentially hostile interstellar comet racing toward Earth. Thumbnails show fireballs hitting cities and countdown clocks, but here is the reality NASA just confirmed. 3IATLAS will miss Earth by about 170 million miles, nearly twice the distance between Earth and the Sun. In the next few minutes, we will shut down the panic with hard numbers and then lean into what actually makes this object incredible, because 3IATLAS really is one of the strangest and most valuable visitors our solar system has ever seen. 3IATLAS is an interstellar comet, only the third known object ever found passing through our solar system from deep space after 1I Oumuamua and 2I Borisov. Interstellar means its orbit is not a closed loop around the Sun, but a one-time fly-through on a hyperbolic path. Astronomers discovered it on July 1st, 2025, with a NASA-funded survey telescope called ATLAS in Chile. When they traced the orbit backward, it clearly came from outside our solar system, telling us this object was wandering the galaxy long before our planet existed. Since then, it has swung towards the inner solar system, reached its closest point to the Sun around October 30th, 2025, just inside the orbit of Mars, and is now on its way back out. Here is the number that matters most for anyone worried about impacts. NASA's calculations say the closest 3IATLAS comes to Earth on this flyby is about 1.8 astronomical units, around 170 million miles, or roughly 270 million kilometers. The average distance from Earth to the Sun is about 93 million miles, so even at its closest approach, this comet is almost twice as far away as the Sun. And this is not just one model from one team. NASA's Small Body Database, NASA Science Pages, the European Space Agency's Planetary Defense Office, and independent ephemeris sites all agree on the same basic geometry: a hyperbolic flyby, a big missed distance, and no impact solutions in the current orbit fits. You might still wonder how scientists can be so sure when space feels so chaotic. The short answer is that they have collected a lot of precise measurements from all over the solar system. Ground-based telescopes first pinned down 3IATLAS, then instruments like the Hubble Space Telescope and the James Webb Space Telescope refined its path. As it raced toward the inner solar system, spacecraft near Mars, including NASA's Mars Reconnaissance Orbiter and MAVEN, along with the ExoMars orbiter from Europe, captured some of the closest views of any interstellar object we have ever seen. Each observation records the comet's position against the background stars at a specific time. String hundreds of those positions together and you get one orbit that fits them all, which tells you where the comet was and where it will be, including exactly how far it comes from Earth. The European Space Agency even treated 3IATLAS as a live drill for planetary defense. By combining Earth-based data with data from Mars orbit, they tested how well we can triangulate the path of a fast-moving outsider. The verdict is clear: the orbit is locked in, and there is no credible way to bend this trajectory into a collision with Earth during this passage. If the math is so boringly safe, why do headlines still talk about danger? Part of the answer is timing and mystery. 3IATLAS brightened dramatically as it neared the Sun, developed a long blue ion tail, and produced the first radio signal ever detected from an interstellar comet. All of that sounds like the trailer for a disaster movie, even though it matches what we expect from an intensely active comet in a strong solar wind. Add in a United States government shutdown that delayed some NASA communications, fuzzy early images, and a few dramatic quotes, and you get a perfect storm for speculation. On social media, the question, could this be alien tech, spreads much faster than, here is a careful explanation of hyperbolic orbital dynamics. So let us talk about that alien angle directly, because it is a huge part of the online conversation. Avi Loeb, a Harvard astrophysicist known for bold ideas, has argued that 3IATLAS might be artificial, or at least that we should keep that possibility open. He points to its brightness changes, color, and trajectory as reasons not to rule out a technological origin too quickly. Most comet researchers disagree. NASA and independent teams highlight clear signs of ordinary comet behavior: a dusty coma, a gas tail, jets of material driven off by sunlight, and a hyperbolic path just like you would expect from an icy body falling in from interstellar space. When you stack up the evidence, the simplest explanation that fits the data is that 3IATLAS is a big active comet from another star system. Here is the key thing for our safety. Even if someone's favorite hypothesis turned out to be right and this object were artificial, the orbit we have measured would still be the same. Whether you imagine a natural snowball or a disguised probe, the hard numbers give the same answer for this passage. It is not hitting Earth. NASA recently released long-awaited images from multiple spacecraft, and they are worth a closer look. The Mars Reconnaissance Orbiter's HiRISE camera caught 3IATLAS as a tiny, fuzzy blob with a bright center and diffuse coma. Exactly what you expect when you are photographing a distant comet from Mars. The MAVEN mission captured it in ultraviolet, highlighting the hydrogen cloud around it, while other missions such as Lucy, Psyche, SOHO, and Stereo watched its tail evolve as it whipped around the Sun. From different angles and with different instruments, the story keeps repeating. A bright core, gas and dust streaming away from the Sun, a tail aligned with the solar wind, and no sharp edges or solid spacecraft-like silhouette. It may not be the crisp science fiction close-up people dreamed of, but it is solid evidence of a very active comet. When NASA and the European Space Agency say there is no threat, they are not just trying to calm social media. There are official systems built to flag anything that actually might be dangerous. Dedicated surveys constantly scan the sky for near-Earth objects. When they find something, they feed the data to central databases that calculate possible future paths. If even a tiny chance of impact shows up in those calculations, the object goes on special watch lists and gets more observing time. 3IATLAS never made those risk tables, because from the very beginning, its missed distance was huge. Planetary defense teams still used it as a training exercise, because it is rare to get an interstellar object this bright and this well observed, but they used it to practice response tools, not to prepare for an emergency. So where does the story go from here? Around December 19, 2025, 3IATLAS makes its closest flyby of Earth, cruising by at roughly 170 million miles. Astronomers with large telescopes in the northern hemisphere hope to catch it as it climbs back into darker skies after its swing behind the Sun. Through early 2026, the comet will head outward, crossing the orbit of Jupiter in the spring, and then fading as it leaves the inner solar system for good. It will never loop back. The same hyperbolic path that brought it in will fling it back into the galaxy at tens of thousands of miles per hour. New data will keep arriving along the way, but none of it is expected to change the basic safety story. The geometry of the flyby is already set. If it is not a threat, why are scientists so obsessed with it? Because 3IATLAS may be billions of years older than the Sun and carries frozen material from a star system that formed long before ours. By analyzing its ices and dust, researchers can compare the chemistry of other cosmic neighborhoods to our own and learn how common certain building blocks of planets and life might be. It is also only the third time in history that we have caught an interstellar visitor with modern telescopes and spacecraft. Every new object like this fills in another piece of the puzzle about how common planetary systems are, how they evolve, and how many chunks of rock and ice get thrown into interstellar space. For people who enjoy the what-if side of science, 3IATLAS is a perfect playground. You can test wild ideas against real data. You can ask, if this were artificial, what would we see? And then compare that to the measurements and see which possibilities survive. So here is where we land. Yes, 3IATLAS is fast, strange, and full of surprises. Yes, it has sparked debates about aliens, glowing blue tails, and mysterious radio emissions. But when you strip away the drama and look at the orbit, one fact dominates everything else. This interstellar comet misses Earth by a gigantic margin. Instead of worrying that it is coming for us, we get to do something much rarer and more exciting. We get to watch, measure, and learn from a traveler that has spent millions or even billions of years in deep space and is now cutting across our solar system once, then disappearing forever. This is not the story of a hidden impact threat. It is the story of how good our sky-watching systems have become, how carefully we can track danger, and how much wonder we can squeeze out of a visitor that never comes anywhere near hitting us.